So what we're talking about is which processes can trigger a sudden increase in the coastal sea level, causing flooding. Okay, so which processes? And the key message of today's lecture is actually that it's the combination of processes that can be disastrous. Okay? For example, we have tides. Okay, tides are variations in the height of the sea level caused by astronomical forces, and you have a sea level varying between the high tide and the low tide. Okay, on time scales of either 12 hours or 24 hours. Okay, and you'll learn more about the tides in later lectures. Anyway, so now what really matters is in case of flooding, well, if you have a high tide, the risk of flooding is bigger compared to the situation of having a low tide. Then, in addition to that, you have waves. You have wind wave swell, and so-called a wave setup that can lead to an increase the coastal sea level on top of what the tide prescribes. Okay, you can have a wind-driven sea level setup, and we talk about that on the next slide. You also have an inverted barometer effect, and this is relevant to tropical cyclones. Okay, well, I've discussed that. That goes back to Niels Gisler from 1715 to 1771, and Kelvin waves. Kelvin waves is a fascinating feature because you can have waves which actually travel along the coast. They can be remotely created and traveling along the coast, and they can lead to flooding, if you have a high tide and so. I'll show you an example. And indeed, you have the flooding on land that we will not discuss. Okay, so the land effect. Okay, so let's do it step by step now, okay?